So here we're going to look at a model of intertemporal prices. So a monopolist has to set prices in period 1 and period 2, but there's some level of addiction for consumers. And so the more they consume in period 1, the more they are going to consume in period 2. So we're going to have linear costs and myopic customers. Myopic just means that they're not farsighted. And so the idea is that they don't think about how their behavior today is going to impact their behavior tomorrow. And so this might be reasonable, thinking about someone who's starting to smoke cigarettes or eat that bag of potato chips, anything that could be addictive. Often I think it's reasonable to think of consumers as behaving myopically. So the degree of consumer addiction in period T, which is really going to be period 2, is going to depend on how much they consumed in the previous period. And Z is going to be our addiction parameter. So if Z is 0, then there's no addiction. And when Z is positive, there is. And so our addictive amount is just AD is equal to Z times however much you consumed in the last period. So we're going to have a 2-period demand. And so demand is going to be, our inverse demand curve is just P equals A minus BQ plus AD. And that's the addiction. And so we substitute in for that as ZQ T minus 1. And the firm's goal is to maximize profit from periods 1 and 2 with respect to Q1 and Q2. So how much they produce in Q1 and Q2. So it's really a monopoly model, but we need to solve it backwards in order to figure out how much they should produce in each period. So in the second period, right, the last period, the firm's profit is A minus B Q2 plus Z Q1 times Q2. So this is the price times the quantity minus C times Q2. We solve the first order condition. A minus 2 BQ2 plus ZQ1 minus C equals 0. And then that's our amount in period 2. So our best response in period 2 is A plus ZQ1 minus C over 2B. So that's just like our normal monopoly amount, except we have this extra parameter ZQ1. And so the way you can think of it is that there's a spillover effect of the amount that you produce in and sell in period 1 into period 2. And that's going to change our period 1 and 2 amounts. So in the first period, we're just going to substitute in that best response into the period 1 profit. And so our period 1 profit then becomes, the total revenue from period 1 minus total costs plus the profit. So A minus B Q1 times Q1 minus CQ1, so that's minus costs, plus the period 2 profit, A minus B Q2 plus Z Q1 times Q2 minus C Q2, and all of those are the best response that we solved for before. And so when we substitute in for that amount, that A minus C plus ZQ1 over 2B, this is what we get. And so we get the normal first period, A minus BQ1 minus CQ1 times Q1, plus this extra term. And so that extra term is the profit in period 2 in terms of Q1. And so we take the derivative, we get A minus 2BQ1 minus C, that's our normal amount, plus Z times A minus C plus ZQ1 squared over 2B. So this derivative is a little bit harder to take. You could figure it out, but just take my word for it here. And then we can use that in order to find the subgame perfect Nash equilibrium values of output. We're going to focus on prices here. And so our prices here become, in period 1, B times A plus C minus AZ over 2B minus Z, and B times A plus C minus CZ over 2B minus Z. And so if the Z goes away, right, all we get is monopoly profit each time. So nothing different, A plus C over 2. With addiction, we get that our first period profit is actually less than our monopoly profit, and that's less than our period 2 profit. And as we get greater and greater addiction, so as the value of Z goes up, we produce a lower and lower P1 star and a higher P2 star. And the idea there, you think about something like, illegal drugs that are highly addictive. Oh, here, P1 star 0, and then P2 star, okay, now you have to pay a lot of money. Now, one, I think, interesting thing is, can we think of sort of brand loyalty and early adoption as addiction? So, brand names, if people are very brand loyal, then it might be in a firm's interest to have a low first period price, which gets people to buy into the brand, and then increase the price in the second period when you have more brand loyalty. And I think we can think of firms that have followed that strategy. Early adoption we might be able to use this for early adoption as well, where Z now is a sort of measure of a loss in value to early adopters when late adopters purchase an iPad. And so now Z, in terms of being and not positive now, but it would be negative. And so consumption by late adopters lowers the utility of early adopters. And so that's why you have a falling price over time for things like electronics or designer clothing. The last thing we want to talk about in this video is the idea of damaged goods and quality-dependent pricing. And so the idea of damaged goods is basically that you produce two versions of the same good, one better than the other, but it doesn't actually cost you anything more to produce the higher quality one. And in fact, it might cost less because you have to actively damage the lower quality one. And you might do this in order to segment the market. So you make a product and then you make a clone of it basically, but you make something that is worse. And that it happens. We've got examples on the next slide. My favorite example is Tesla right now. So, they sell cars with different ranges, but the economies of scale are such that they put the same battery into every car. Every Model 3, every Model S, every Model X. But it's software that limits the range on the low range batteries. So it's not that the battery is any worse. It's just software doing it. And so they're just segmenting the market with that. It kind of feels like it should be illegal. So an example was Intel with their 486 chip. They introduced a 486SX chip after the 486DX chip, and it was the same except it had an intentionally damaged math coprocessor. And so it was less powerful, but it actually cost more to produce because they had to damage the coprocessor. They have other examples in the book, IBM laser printers, or DVD players that only play DVDs from a certain region. So yeah, firms do this, and it's really just to segment the market.